How about two-point form? Actually, it's almost the same as the point-slope form, but with the two-point form you first have to calculate the slope, and then you have the slope and a point, and then you can actually apply the same procedure as with the point-slope form. So how to get the slope when you have been given 2 points? It's not too difficult, as you can see here in this, wait, I'll show you, in this diagram. So you can see we have 2 points. This point, this is a point in this case, and this is also a point in this case. So what we can do is we can apply the slope triangle. It's called slope triangle, and we say this point, actually it doesn't really matter since we divide later. It doesn't really matter which is point 1 and point 2. I could also say this is point 1 and this is point 2, but you have to distinguish. And we say this is y2, so this is x2. Y2, x2, right? This is y1, x1. We could also say this is y1, x1, y2, x1. This is also possible. But you have to distinguish, right? Point 1 and 2 are 2 different points. And the way how to calculate the slope now is we just subtract. In this case we say y2 minus y1, and we end up with delta y. Delta y we'll need later. Delta means always we have a some sort of difference, so which is y2 minus y1, as I just said. And we have the same thing for x, which is in this case x2 minus x1, and we end up with delta x. Delta again is used as an expression used to indicate there's some sort of difference, which is of course in this case, as I said, x2 minus x1. And then you take those deltas and you can put them into the formula, and then you end up with delta y divided by delta x. So this is y2 minus y1 divided by x2 minus x1, and you end up with the slope. Then you have the slope. Then you can just take a point. Both points are either way. I mean, you can choose the first point or the second point. Both work or should work. You can also calculate. You can make a proof when you use one point and then prove that the other point is also part of the function. That you can do. But in principle, the most important thing is always the slope, and that's usually where people can usually make mistakes. To understand what is the slope of a linear function, and I will also explain it in the video. So you will also see it with an example later. Hi guys, what is the 2-point form? Actually not that difficult, although maybe it sounds difficult, and also actually when I learned it the first time I had some problems with it, but actually it's quite easy, and the principle is we have 2 points, so someone gives us 2 points, and once this someone wants to know the function, the mathematical expression of a linear function going through these 2 points, right? So let's maybe say this is point 1 and this is point 2, x-axis, y-axis, and we want to know this functional term, like the linear function which is going through those 2 points. The general linear function is something like this. We have f of x mx plus c. So this is actually already half of the solution. This is important to memorize. This is a general linear function. That means that all linear functions in the two-dimensional area can be described by this expression. M is the slope, x is the variable, c is the y-axis intercept. Like the c you can always see here. This is the c, like this value. Maybe it's 1 in this case, so c would be 1. And why is that? If we insert, like, you see, there's x, and when we set x 0, then the y value will be what? 1 in this case. So you see, if x is 0, then we just get the c. So the c we receive when x is 0, which is, like in this example, would be 1, right? So c is the y-axis intercept. But now, more important, we want to know something about the slope. Okay, c we just talked about, but what is the slope? The slope works like this. This is the second part of the solution. You should either memorize or you can also understand it, or both. In best case, it is called m is delta y divided by delta x. And what is delta? Delta is a Greek letter, and it means always, in, for example, in physics and in mathematics, it always means like a difference. In this case, actually a distance between two values. So to make it more clear, it is y2 minus y1 divided by x2 minus x1. So this is the second part of the two-point form. You should either know or you understand it or whatever, but you need those two parts to solve this problem. Given 2 points and calculate the linear function going through those 2 points. Okay, but what does it actually mean? So we have delta y divided by delta x, and it means exactly this, p2, so this would be our y2, this would be our y1, and exactly the same thing on the x-axis, this would be x1, and this is most important. Actually, it doesn't really matter later which point is which one, but if one point has y2, then the same point also has x2 as coordinate, right? This is important. So for p1 we have y1 and x1. So it shouldn't be made across. So this is then x2, right? And the thing is, the thing I'm going to show you now, this is called the slope triangle, and this formula is exactly the slope triangle, and we say we divide y2 minus y1, which is this distance, which is this part, right? This branch, and we say x2 minus x1, so it's x2 minus x1 minus this, then we receive this here. So we divide this by this, so we say how many, or we say what distance in this direction do we have for one distance in this direction, right? So we divide this through this, and then this is called the slope. That's the definition, right? So this you should know to calculate m, and c obviously is very easy, we already talked about it. C is always the y-axis intercept. So with this information we can already solve an example. So let's just calculate an example. We have 2 dots, one is called P, which is minus 2, 1, the other one is called Q, which is minus 6, 9. And we say P is like x1, y1, and Q is x2, y2. So as I said, that doesn't really matter which is 1 and 2, but if I have x1 in one point, then I have to have y1 also in the same point. And then I just have to apply the formula. I can get m, which we will just do. So y2, which is 9, 9 minus 1 divided by x2 minus 6 minus 2. 9 minus 1 is 8. This is actually then a plus. You can say plus. So minus 6 plus 2 minus 4, 2, 1 minus 2. So that's really, there we see how easy it is actually. So we have the slope of minus 2, and all we need to do now, we insert it in the general function, which is minus 2x plus c The c we don't know yet, but doesn't matter since we can calculate it. So we have, but the thing we do now, we insert a point. It doesn't matter if we insert p or q, but in this case p seems to be a little bit easier, so we just insert p. So we insert -2, since this is the x value, right? So -2 times -2, the x value, plus c, which we don't know yet, is 1. So then we calculate it. -2 times -2 is 4, plus c is 1. C is 1 minus 4. So c is -3. So that's, there you see really that it's quite easy. Just have to pay attention not to get confused here or calculating the slope, but actually if you don't get confused, then it's quite easy. So then the final step is just to write down the function, which is, okay, slope we calculated -2x minus 3, and -3 is the y-axis intercept. That's the solution. So you see how easy it actually is. You just have to memorize, or you have to be able to write it down. This one, the general term of a linear function, and this one, which is the definition of the slope of a linear function, right? In this case of a linear function, the general definition looks quite similar. A little bit more complicated, but this you can use for a linear function. So you see, quite easy actually in principle. The numbers may be a little bit difficult in exams, but the principle is always the same. So if you practice it a little bit, then you're also able, I'm sure then you're also able to do it in an exam. Okay, thanks for watching. Practice makes perfect. Further exercises with solutions you can find on my website, which is www.worksheets.com.